Alright, so fundamentals, right? Java, we say how Java works, how it works under the hood. Right now, we say Java is a platform independent language. Okay, so what does this mean? Platform independent means that, let's say today I have a Windows operating system, tomorrow I have a Mac operating system, on the third day I have a Linux operating system. Irrespective of which operating system you have, my Java code would execute. Java code, the program that we learn, right? My Java program would execute irrespective of which environment we write it in. Alright, so that is called as platform independent. Alright, you run it in any programming language, you run it in any environment, any operating system, my Java code would execute. Okay, so that is why we call Java as platform independent. Okay, so now Java development environment consists of two things: Java JVM, that is Java Virtual Machine, and the application programming interface. I'm going to explain this, like it might be big word, but let's break it down into very simple things, right? So what is Java Virtual Machine, Java JVM? So it is the base of Java platform and ported to various Java environments. So let's say I wrote a program today. We wrote a program called as. Oh goodness. Okay. It works. Okay, so let's say we wrote a program today called as Selenium scripts, right? This is what we wrote, Selenium script.java, right? This is what we wrote. Okay, this is what we wrote. So this programming language, what we use is Windows operating system, correct? So this is my program. Okay. So how does it work is basically this program, when it will execute, okay, when it will move ahead, alright, it goes into something called as a machine code or assembly code. Okay, this code that will get generated is independent of the platform. Let's break it down more. Anybody can how is Java independent of any operating system? So you can run the machines. Any Java programming language, in a Java programming language, all your source code would first be converted into plain text files. Okay, and these will be converted into .class files. So let's say I write a program Selenium script.java. So first this program will get converted into Selenium script.class. Alright, this is what it gets converted into. So this is a compiled file which a Java compiler will do. So what is a Java compiler? It compiles the file. What is a compiler? It converts a program, it converts a high level language into a low level language or a machine language. Or this language we are able to understand, right? And this language your machine will be able to understand. Your hardware or your machine will be able to understand. Okay? So it compiles a language. A compiler will convert a high level language into a machine level language, or a machine level language which the machine will be able to understand. Makes sense up till now? So first I write a code called as Selenium script.java. This is compiled and I create a file called as Selenium script.class. This the compiler will create. Okay, this file is created and I have it. See here, if you see, my program.java got converted into my program.class, right? So let's understand it. A .class file does not contain code that is native to your processor. It instead contains bytecode. In machine language of JVM, the Java launcher tool then runs your application with an instance of Java virtual machine. So what happens is, when this compiler converts it into this file, this is independent of the platform which you are using. So it can be a Windows operating system, it can be a Mac operating system, it can be any operating system which you are writing the code in. But this code that is created is irrespective of which operating system you are writing. Okay, this takes the operating system environment out of the picture itself. Alright, so when it is compiled and converted into machine code, this code can work on any machine. That's how it's created. Makes sense? Keeping it more simple, this is a high level programming language that we write the code in. Okay, you break it down into a code that machine can understand, and this can be understood by any operating system. It can be a Mac operating system, it can be a Windows operating system, it can be a Linux operating system. This code which is compiled is independent of the operating system.
Who is compiled?
This script is converted, this code, this file is converted into, compiled and converted into this code.
Does it convert through myprogram.class? What is that? Is it?
I have written a code in .java file. Alright, I have written a code. This code, what happens is compiled with a JavaC compiler and a new file is created .class. Makes sense up till now? This .class file that is created here, this is how this is in a machine level code. So let's say it would be something like 0 1 1 0 0 1 0 1 1 1 0 0 0. That's how it gets converted. Okay. Now this is independent of any operating system. So this language can be understood by, let's say, Mac. This can be understood by Linux. This can be understood by Windows. Any operating system can understand these rows of zeros and ones. Okay, makes sense up till now. Now what happens is this code. So let's say I have, okay, I am writing my code in Windows operating system. Alright, I have written my code, and this code got converted into your byte code or machine code, whatever you say. So now this class file, what I'm going to do is I have a new system and I have something called as a Linux operating system. Alright. So first what I'm going to do is I'm going to install JVM, Java Virtual Machine. Okay, this Java virtual machine is compatible with any operating system. So today it might be Linux, tomorrow it might be Windows. So on any of these operating system, JVM can sit over it. Okay, JVM can sit on it. Alright, today I am writing of, let's say, Windows. So I have a JVM over it. Tomorrow I am writing my code in Linux. I can install JVM on it. Alright, this Java virtual machine can get installed on any operating system. It can also get installed on Mac. It can also get installed on, let's say, uh, Linux, Windows, Mac. Any operating system you choose, you can install JVM, Java virtual machine. Okay, some new concept here. This code converts into bytecode, which is independent of any operating system. But on each operating system, you can have Java virtual machine installed. Okay. Alright, makes sense up till now. Okay, so now I have, let's say I have a Linux operating system on which JVM is sitting, JVM, Java Virtual Machine. Okay, so now what does this JVM do? Any idea what would it do? What does this JVM do?
JVM is Java Virtual Machine,
Right.
which reads code.
True.
So, Java Selenium script, seleniumscript.com.
Hmm.
Oh, wait a second. Yeah. So JavaScript, right?
Yeah.
It reads by Java, by Selenium virtual machine.
Okay.
So it helps you with this.
So is it gonna like convert the code into the machine understandable language that is 0100?
Yes. So now this JVM has been installed on these operating systems, right? Linux, Mac, Windows, any operating system. So whenever what it does is basically this code will be understood by the Java virtual machine, all right, and this JVM would, instead of these operating system which would run it, JVM is going to execute it for you. Okay, how does it work in Linux, Windows, and Mac? Because JVM can get installed on any of these operating systems. Okay, Java virtual machine can get installed on Linux. Tomorrow it can get installed on Windows. Next day it can get installed on Mac. Okay, any operating system JVM can get installed, and this bytecode JVM will understand it and run it for you. Java virtual machine. No?
Okay, so first we have to have compiler and then we have to have JVM.
Yes.
For the complete function.
So yeah, for the complete run. Okay, entire flow, let's try to understand one last time. Okay, so I have written my code. I have written my code as .java file. I put it into a Java C compiler. It converts it into a bytecode 011000. Okay, I have a .class file now. Next step is this code will get inputted into, let's say tomorrow I'm taking into a Linux operating system. I take this .class file. I install JV on my operating system, let's say Linux or Mac, any operating system, and then I'm going to run this code. JVM will take this bytecode as input and run my program for me. Okay, and how does it become platform independent? Because Java virtual machine is platform independent. It can sit on Linux, it can sit on Windows, it can sit on Mac, it can sit on Solaris, any operating system. So that's how Java becomes a platform independent language. Alright, if you see, this is just from the Oracle documentation, so straight from the horse's mouth, right? So the source files are then compiled to .class files by JavaC. A .class file does not contain code that is native to your processor. It contains bytecode. The machine language of Java virtual machine. The Java launcher tool then runs your application with an instance of JVM. So when you launch it, there's a tool called a Java launcher tool. It will start JVM and it will run your code for you. Okay, so if you want, there is another concept called a Java launcher tool, which would run your application by starting off JVM. So JVM will run your code, and to start JVM, we need a launcher tool, Java launcher tool. Okay. Alright, so makes sense. Because the Java virtual machine is available on many different operating systems, the same file are running on Microsoft Windows, Solaris operating system, Linux, Mac. Some virtual machines, Java SE hotspot, performs additional steps at runtime to give your application a performance boost. This includes various tasks such as finding performance bottlenecks and recompiling frequently used section of codes. So, is it clear how it works? Is it clear? Alright, so breaking it down into simple, see, this is what has been done. The Java program has been written, compiler will create it into .class file, and this .class file can be run in Windows 32, Unix, and Mac operating system. Okay, so that's how it's running. Make sense? Or no?
I think you should drink some water.
Yes, it does. So why do we need this for testing?
At that point of time. So just to understand what is happening under the hood, right? That is the idea here. Alright. So let's end it here, right now, and next time we will continue ahead.
Can you start soon?